Welcome to the video guys. In this video we are going to talk about atomic structure. In this video I will be covering every important points in our syllabus. Please take notes and please do not forget to revise the notes. If you don't revise, no use of watching this video. I hope you guys are ready. Let's discuss about atomic structure. What is atomic structure? Atomic structure is how the atoms are made. Different scientists explain different kind of atomic theories. In our syllabus, we have around 16 scientists. The first scientist is Amphilosols. Amphilosols. Four elements: earth, fire, air, water made up all the things. Let's write it down. Four elements. That is air, water, fire, and earth made all the things. The next scientist is Democritus. Democritus. What did Democritus say? Democritus. World is made up of tiny invisible particles. The invisible particles are called as atomos. That's what Democritus says. World is made up of tiny particles. Those tiny particles are called as atomos. The third scientist is Aristotle and Plato. Aristotle and Plato. What did Aristotle and Plato say about the atoms? He said there can be no ultimately indivisible particle. Next we have John Dalton. John Dalton. John Dalton. What is the model he proposed? John Dalton, Gulf ball model. He proposed the Gulf ball model and atomic theory. Atomic theory. What is atomic theory? Atomic theory has four main principles. Four main principles. Let's first. The first principle was elements are made out of extremely small, are made out of extremely small, indivisible particles. In extremely small, indivisible particles called atoms. Indivisible particles called atoms. John Dalton's second principle: all the atoms of given elements are identical in mass and size, but the atoms from one elements are different from other atoms of all other elements. Okay, let's write it down. All atoms of an element are identical in mass and size. Mass and size. But all but the atoms are different from different from atoms atoms of different elements. Third point, third principle, atom of one element cannot be changed into atoms of different elements by the chemical reaction. Atoms are neither be created nor destroyed in the chemical reaction. And okay, atoms of one element cannot be changed. Atoms of one element cannot be changed. Element cannot be changed to another element. Atoms of elements cannot be changed into atoms of another element. Atoms of another element. Atoms of another element. And atoms are neither created nor destroyed. Atoms are neither created nor destroyed in chemical reaction. In chemical reaction. What does he mean by an atom cannot be changed from one atom to one element's atom to another element's atom? The compounds are formed by union of two or more atoms of different elements in numerical ratio. Compounds are formed by union of two or more atoms of different elements in a numerical ratio. The fifth scientist is Johnston G. Stoney. Johnston G. Stoney. Who is he? What did he say about the atoms and its atomic structures? He named the fundamental unit which carry electricity as electrons. Let's write it down. Named the fundamental unit carrying. Okay. Our next scientist is William Crookes, who discovered Crookes tube. William Crookes. He found Crookes tube, or we call it as cathode ray tube. William Crookes is the one who discovered cathode rays. Let's talk about the setup of cathode ray. Two electrodes are connected in high voltage source, and the cathode produces invisible rays. Cathode produces invisible streams of radiation. They form invisible stream of radiation, which we call as cathode rays. Presence of cathode rays can be detected in low pressure, which gives a glow in low pressure. Cathode ray gives glow in low pressure. Let's write that point. presence of cathode ray can be detected in low pressure because cathode because the cathode rays gives a glow in low pressure. Cathode ray gives a glow in low pressure. This cathode ray make other substances fluorescence, which made the other substances fluorescence. In our syllabus, we have sixth scientist is William Crookes, and next scientist who is J.J. Thomson. Talk about J.J. Thomson. J.J. Thomson. He is the one who introduced Plum pudding model and found the electrons charge over mass ratio. He's the one who found plum pudding model. He's the one who found the plum pudding model. And his second invention, electrons charge over mass ratio, found at 1.7 into 10 to the power 8 coulombs per kilogram. J.J. Thomson did 4 experiments. One, he found out, with one first experiment, he found out the cathode rays travel in straight lines. And the second experiment, he found out that cathode rays have mass and possess kinetic energy. And the third experiment, he found out cathode rays are negatively charged. And the fourth experiment, he found out that the nature of the cathode rays does not depend on the nature of the gas intaken or material of the cathode. Let's try to note it down. Okay, the first experiment, cathode rays travels in straight lines. Cathode rays travels in straight line. How did he say that the cathode rays travels in a straight line? When he kept a Maltese cross, it formed sharp shadows. They produce sharp shadows. And the second one, having mass, cathode rays having mass and possess kinetic energy. How did he confirm this? He kept a paddle wheel, the blades of the paddle wheel. He kept in relation the blades of the paddle wheel. When the cathode ray hits the paddle wheel started rotating. Okay. Blades of the paddle wheel rotated. In the third experiment, he proved that cathode rays are negatively charged. Cathode rays are negatively charged. These are heading right. Properties of cathode ray. Properties of cathode rays. Properties of cathode rays. They are negatively charged. How did he prove that the cathode rays are negatively charged? He proved it's negatively charged placing electric field. He placed the electric field, it deflected towards the positive plate. The rays deflected to the positive plate. Deflected towards the positive plate when when kept in electric field, when kept in the electric field. It also deflected to magnetic field in the direction where the electrons are deflected. It deflected in the same direction as electron deflected. We'll write it down. Deflected in the direction of electrons deflected when kept in a magnetic field. The fourth point, nature of cathode ray does not depend on the gas used or the material of the cathode. Nature of cathode rays doesn't depend on nature of gas used in cathode ray tube. Gas used in cathode ray tube or material used in cathode, material used as cathode. How did he prove this? The ratio of E over M ratio, charge over mass ratio, was same of the cathode rays obtained from different gases and different cathodes, different cathode materials. It was exactly the same. EM the EM ratio was exactly the same. EM ratio was exactly the same. Okay, we'll draw the Thomson's plum pudding model. We'll draw that. This is an atom. He said that it's like a plum in pudding. Negative charge, negative charge, negative charge, negative charge, and it has positive charge all over the place. It's just spreaded. This is J.J. Thomson's plum pudding model. J.J. Thomson's plum pudding model. J.J. Thomson's plum pudding model. Our next scientist is Robert Millikan. Robert Millikan, scientist number 8. Robert Millikan. He is the one who measured the charge of an electron. He measured the charge of the electron. The charge of the electron. So the charge of the electron is as 1.602 into 10 to the power minus 19 coulombs. Okay, how did he say the charge of the electron is 1.602 into 10 to the power minus 19 coulombs? He performed oil drop experiment. He found out charge of the electron by the oil drop experiment. And he also found the mass of the electron using J.J. Thomson's charge over mass ratio, E over M ratio. Okay, we'll write those. So E over M ratio. We found the charge. Charge, as you know, we know charge is this is the electron charge. Charge he found out 1.602 into 10 to the power minus 16. Sorry, 10 to the power minus 19 coulombs divided by mass equals to J.J. Thomson's EOM ratio. J.J. Thomson said EOM ratio is 1.76 into 10 to the power 8 coulombs per gram. And he subjected the mass M, and he found out that the mass of the electron is 9.1 into 10 to the power 28 grams, and its mass is about 1/1 of 1837 of a H hydrogen atom. And he found that the relative charge is -1. Relative charge of the electron is -1. The relative charge, he found the relative charge of electron as -1. Our next heading is nucleus of an atom. Nucleus of the atom. The next scientist is Eugen Goldstein, who is the ninth scientist. Eugen Goldstein. Above, this positive charge is on the sphere. The sphere is positively charged and the electron is scattered all over. Here Eugen Goldstein, who proved the existence of positive rays, which we call as canal rays. He proved the existence of positive rays as canal rays. How did he perform this? How did he prove the existence of positive rays? He used a perforated cathode in a discharge tube at low pressure and high voltage supply across 10,000 voltage. And he observed a faint red glow behind the perforated cathode. Okay, let's write it down. Write the note. He used a perforated cathode in discharged tube with he used the tube with at low pressure and high voltage around 10,000 volts. 10,000 volt across the electrodes. And he observed a faint glow. What did he observe? He observed a faint red glow behind the perforated cathode. He saw a faint red glow behind the perforated cathode. What's property? Similar to canal. They travel in straight lines. And car shadow. They travel in. And the second property, can rotate pedal wheel. And the third one, discharge towards a positively charged reason deflected towards negative plate. This is the reflected towards the negative plate. The fourth property is nature of the positive rays depends on gas intake in the tube. Nature of positive rays depends on the gas intaken. EM ratio was not constant. EOM ratio wasn't constant. It's not constant. When they change the gas, the EM ratio changes. Let's look at the difference between the canal rays and similarities between the canal rays. The first two properties are same for canal and cathode rays, and the third and fourth point is different. They deflect towards the negative plate. Cathode rays deflect towards the negative plate, and the canal rays deflect towards the positive plates. And the nature of the negative, I mean, the cathode rays does not depend on the gas intake, but the nature of the cathode ray depends on the gas. So nature of the canal rays depends on the gas. Nature of the canal rays depends on the gas intake. Therefore, the EM ratio changes. And now we'll talk about proton. Proton. Okay. Mass of proton. Mass of proton is 1840 times the mass of an electron. 1840 times the mass of the electron. And we found the mass of the electron as, which is proton as 1.6 into 10 to the power minus 24 grams. Or we can take it as 1.007276 U. U means atomic mass units. Atomic mass units. Or we can take it as 1.007276 Daltons. TA. Daltons. The Daltons and atomic mass unit U are similar. Both are same. And charge. Okay. Charge of a proton is plus 1. Is plus 1. The number of charge is opposite of the electron. Number of charge in proton is opposite of electrons. It is 1.6 into 10 to the power minus 19 coulombs. Charge of a proton is equal and opposite. 1.9 into 10 to the power minus 19 coulombs, but it's positively charged. But the electron's charge is negatively charged. Next scientist number 10 is Henry Becquerel. Henry Becquerel, who he is the founder of radioactivity. And the 11th scientist is 11th one, Ernest Rutherford. Okay, Ernest Rutherford. Ernest Rutherford. Ernest Rutherford. He found that the radioactive materials produce 3 particles, alpha, beta, and gamma. He found that radioactive radioactive materials. Found the radioactive materials produce three particles. Those are alpha, beta, and gamma. And they bend towards the magnetic field. They are bent. Okay, I'm ready. Alpha, beta, gamma, gamma, bent in magnetic field. Bent in magnetic field. In electric field, in electric field, electric field, alpha deflected towards the alpha deflected towards negative plate. Therefore, it is positive ray, and the beta deflected towards the positive deflection. The positive plate. Therefore, it is negative ray. Beta is negative ray, and the gamma is not does not reflect. No charge in gamma doesn't reflect. Therefore, we can tell it does not have charge. No charge. We call this as gamma as high energy ray. We call this as high energy. X-rays and gamma rays. X-rays and gamma rays does not undergo any deflection. X-rays, X-rays and gamma rays do not deflect to magnetic or electric field. Does not deflect to magnetic or electric field. Okay, let's talk alpha. Alpha has 4 and these 2. Beta, 0 and -1. This is +2. Charge +2. That has 4. Beta we can call it as fast moving electron, and the gamma has 0, 0. No charge, no mass, but it has high energy. Our next scientist is the 12th scientist. 12th scientist is Rutherford. Rutherford. Rutherford, who did he did gold foil experiment. Rutherford did gold foil experiment. Rutherford, William Geiger, and Ernest Marsden. They used a very thin gold foil to target alpha particle from a radioactive source. They used used a very thin gold foil to target alpha particle from a radioactive source. And that thin foil is surrounded by a circular fluorescent screen. I'll draw and show. There is a source and there is a thin foil. It is surrounded by a fluorescence screen. It is surrounded by a fluorescent screen. This is the screen, and the source is here. They emit alpha particles. They emit alpha particles. Some of the alpha particles penetrate in. They penetrate into the and deflect here. When an alpha particle hit on the fluorescent screen, it emit light. And some of the particles, what happened? They slightly deflected, and some few particles reflected back. They reflected back like this, and most of the particles penetrate towards into the penetrated in, and some of the particles only reflected, very less, but some. Few particles hit the gold foil and turn backwards. Very few particles. Most of the particles hit to the fluorescent screen, and few particles deflected, and very few particles came back in the direction it went. This is the fluorescence screen. This is the gold foil, thin gold foil, and this is the radioactive source. Let's write the observations now. Observations. Observation number 1. Many of the particles, we'll write in the same color as we marked in the diagram, above diagram. Many alpha particles penetrated the foil. Either unreflected or with slight reflection. Few alpha particles are scattered at large angle, and very few of them, third point, very few alpha particles bounce back in the direction where it came from. In the direction where it came from. What is the explanation? Let's write down the explanation. We can say that most of the atom is empty. Most of the atom is empty, and positive charges are centered. Positive charges are concentrated into in the center. We call as nucleus. We call as nucleus. This is one and this is two. Let's draw the structure. These are the electrons. This is nucleus. These are electrons. In our syllabus, the next scientist is scientist number 30, who is James Chadwick. Chadwick. He's the one who discovered neutron. Discovered discovered neutron. Okay, let's see. Neutron charge. Charge of neutron is 0. Mass of neutron. Mass of neutron 1.6749 into 10 to the power minus 24 grams, or mass 1.008665 AMU. The mass of neutron is similar to mass of the proton, almost very similar. Our next scientist is Niels Bohr. His full name is Niels Henrik David Bohr. Niels Henrik David Bohr. Niels Bohr postulated that the electrons are moving in orbits around the nucleus. Electrons are moving around the nucleus like our solar system. And the electrons, in order to remain in the orbit, the electrostatic attraction between the nucleus and the electrons must be equal to the centrifugal force. He said that the electrons are orbiting around the nucleus like Earth orbiting around the Sun. To keep the distance constant, the electron must move in a constant speed around the nucleus. We'll write the note down. Niels Bohr. Electrons are orbiting around the nucleus as Earth orbiting around the Sun. And the other idea of him, in order to maintain the distance between the electron and nucleus, electrons should travel in constant speed. And also electrostatic force between electron and nucleus equal to centrifugal force. And they name this model as Rutherford's and Bohr model. The Rutherford's Bohr model. What are nucleons? What is nucleons? Nucleons. The particles found in the nucleus are called nucleons. Particles found in the nucleus. Particles found in the nucleus. Particles found in the nucleus is called nucleons. And now, what is nuclide? What is nuclide? Nuclide is the nucleus of an atom that has specific specific number of protons and neutrons. They are called as nuclides. We can call it as also like this. Nuclides are composites of particles of nucleons. Now let's go to Bose model. Let's look at the Bose model. Bose model. This is the Bohr model where the electrons are here, and there is an electron. In this capital has electron. So there might be an electron here. Okay. Center point has the nucleus. This is the Niels Bohr model. Bohr model. We call it as Bohr model. Now let's look at the heading, subtopic, atomic number, isotopes and mass number. Let's write the heading. Atomic number, isotopes and mass number. This is our next topic we are going to discuss about. Here comes the 15th scientist. 15th scientist. Who is it? Henry Cohen, Jeffrey Moseley. Henry Cohen, Jeffrey Moseley. He's the one who introduced atomic number. Introduced atomic number. What is atomic number? Let's look at what is atomic number. Atomic number is number of protons in an atom of any particular element is called as atomic number. There is an equation for atomic number. Let's look at that equation. Atomic number, the symbol of atomic number is Z equals to number of protons in the nucleus. Number of proton in the nucleus is equal to number of electrons in the nucleus. Number of proton in the nucleus is equal to number of electron in the nucleus is equal to atomic number. This is atomic number. Here comes the 16th scientist. 16th scientist, who is Francis William Aston and our J.J. Thomson. They perfected the spectrometer. Spectrometer. mass spectrometer, right? This perfected the mass spectrometer. This perfected the mass spectrometer, and they discovered the first isotope. First isotope. They found the first isotope of neon. Now let's discuss about mass number. Mass number. What is mass number? Let's write it down in a simple equation. Mass number, symbol A equals to number of protons Z plus number of neutrons. What is this Z? Number of proton is equal to atomic number. You can call it as atomic number, or we can call it as number of electrons. This is the equation. Let's look at how the atomic symbols are represented. Okay, let's look at carbon. Carbon C 12 6, carbon 612. Here the central C is atomic symbol. It is atomic symbol. Atomic symbol is the atomic number. Z. Atomic number Z, which is the mass number. Mass number A. This is how we represent the atomic symbol of an element. Okay, now let's look at what is isotope. What is isotope? Isotopes. An atom. Okay, what is isotope? Atom with identical atomic number but different mass number. Reason for this, same number of protons but different number of neutrons. Let's write it down. What is isotope? Atoms with identical atomic number but different mass number. What is the reason? Same number of protons but different number of neutrons. Same number of protons but different number of neutrons. There are two types of isotopes: stable isotope and radioisotopes. Stable isotope and radioisotope. What is stable isotope? Stable isotope is in the name. The isotope of an element which is stable in nature. Isotope of an element which is stable in nature. Isotope of an element which is stable in nature. And the next one is radioisotope. Isotope of an element which is unstable. Isotope of an element which is unstable in nature. The next topic is atomic mass scale. Atomic mass scale. The atoms are very small. We use AMU, Unified Atomic Mass Unit, symbol U, to deal with extremely small masses. We use to measure the mass of atoms. We use the symbol. We use the symbol atomic unified atomic mass unit. Symbol is U. We can define atomic mass unit as mass of an exactly 1/12 of chemically unbounded C612 carbon. Let's write it down. 1/12 mass of 1/12 of C carbon. Okay. What is atomic mass unit? Mass of an atom is called as atomic mass unit. What is average atomic mass unit? What is average atomic mass unit? Average atomic mass unit. Average atomic mass unit, we can take it as is sigma bracket isotopes into fraction of isotope abundance. Fraction of isotope abundance. Okay. Now let's look at what is molar mass. What is molar mass? Molar mass. What is molar mass? Atomic mass given as per mole. Symbol clan for mole minus 1. 1 mole of atom contains 1 mole of atom contains how many number of atoms? It contains 6.022 into 10 to the power 23 atoms. Okay, now let's look at what is relative atomic mass. Relative atomic mass. Symbol we use as A. We define it as ratio between mass, average mass of an atom, average mass of an atom, of an element, to 1/12 mass of an atom of carbon 612 is known as relative atomic mass. Okay, this is the equation for AR. Okay. What are ions? Ions are charged particles. Ions are the charged particles. What are cations? Cations and anions. What is cation? What is anion? Cation means positive charge particle. Anion means negatively charged particle.
Na plus. We write this charges in superscript. Superscript. There are the two types of ions. There are simple ions and polyatomic ions. What are simple ions? What are polyatomic ions? I'll write example. You will understand this. Sodium plus simple atom. Cu2 plus simple atom. Chlorine minus simple atom. Polyatoms are NH4 plus, SO42 minus. These are polyatoms. It contains two elements. They are joined atoms. They can be either positive or negative net charges. That's all for atomic structure 1.1. Atomic theory of matter. Thanks for watching.
Don't forget to subscribe, like, and share.